All right, here we go. It's math time, and I'm gonna be really blunt and say my Steadicam isn't so steady today. But we're still gonna do it, okay? Just do it. So forgive me, it's a little wompy-compy. You know, it's like homework on the main. Look at, you can see the date. Ba-ding-a-ding. Okay, so we're just gonna go through this idea, precalculus, yada you, yada ye. I'm sorry about this. I'm gonna have to edit this out. This is annoying. I don't deny. Oh, hi. That this is annoying. Let's get this fixed, right? Oy, oy. Okay, here we go. So, I have to shut that light out. It's actually part of the problem. Except for my eyeballs. Okay, so function is, can we see this here? Are we cool? Function is 2x squared minus x plus minus 1, okay? And then it has these questions. Is the point -1, 2 on the graph? If x is -2, what is the function? If the function is -1, what points are on the graph of f? And the domain range intercepts, if any. Okay, so, hold on. There we go. We've got some there. I think that helped. Maybe, I don't know. I'm not a fan of this right now. I'm hoping you guys can see that. So we're going to look at this. So just so you know that this little caret symbol, it's the only way to get it in the equation. So I'm going to rewrite this here. 2x squared minus x minus 1. Okay, that's what that is. So we're asked now, is the point -1, 2 on the graph? So what that means is, okay, I'm trying to help you interpret what these questions are. What that means is, if we put -1 in for x, do we get out +2? If the answer is yes, then yes, that point is on the graph. If the answer is no, then no, it is not. So let's go ahead and put in -1, okay? So f of -1 is 2 times -1 squared minus -1 minus 1. Okay, do you see what I did there? I put this parentheses around -1 every time, including there, so that I did not lose track of my plus minus. Okay, so now this stays the same. Nothing happens with this. If you're wondering about function notation, this is the function of -1. This never changes. There's not an operation happening there. Okay, this is like a name. This is saying function, and in this case, for this problem, it's this function over here, right? Of -1. That equals 2 times, well, order of operation, -1 squared. -1 times -1 is +1. -1 times -1 is +1 minus 1. Okay? 2 times 1 is 2 plus 1 minus 1. Now, you might just say, okay, those are opposites. They go away. You could also say 2 plus 1 is 3 minus 1 is 2. The answer is 2. So we put in -1. We got out 2. Is the point on the graph? Yes, it is. If I did a TikTok review of this GoPro arm, I'd be like, it's too shaky. Okay, so now we're asked a question another way. If x equals -2, what is the function? Same question, but now it's open-ended. Okay, this one was a yes-no. We still had to solve it, but it was a yes-no. Okay, what we are doing now is the exact same thing, but instead of putting in -1, we're putting in -2. So let's do that. We'll do it in green. Okay, we're just going to scroll. So let's rewrite our original function. Our function is f of x equals 2x squared minus x minus 1. Okay, you see that? So now we're saying, what is the function at -2? That's what we want to know. 2 times -2 squared minus -2 minus 1. You see that? Well, order of operation. This is a lot of 2's, but we're interpreting what's going on, right? Nothing happens here. This is a name. This is like saying, Miss Thompson, this. Okay, these are the operations. But this stays the same because it's saying this is what happens. This is what happens here. Okay, order of operations, this goes first. -2 squared is, survey says, -2 times -2 is 4. Negative minus 2 is plus 4. Or excuse me, oopie-doopie-doo. Plus 2 minus 1. 2 times 4 is 8. I came in like a wrecking ball. All right, let's scroll up. If x equals negative 2, what is the function of x? It is, we know it right there, 9. 9. F of negative 2 equals 9. Okay? Next question. If f of x equals negative 1, what points are on the graph? So now what we're doing is we're solving for x. This is the part that we have, okay? So let's actually, maybe we have room right here. Let's rewrite the equation. And now we're saying we have this answer. This is negative 1. What do? How do we solve this? Okay, this is inherently more difficult than these. These are, as my teacher used to call, plug and chug of my infinite number of teachers. And now I am yours, young Padawan. Okay, what is this? How do we solve this? Do you remember factoring? Set it equal to 0. Okay, so the logic behind setting it equal to 0 is that when you factor anything, if you can create a multiplication equal to 0, that means one or both parts have to be 0 and it gives you your solutions. So let's go ahead and rewrite this with the equal sign on the other end. Okay, and watch what happens. 2x squared minus x minus 1 equals negative 1. Are you with me? Now we need to red rover this over because we're going to set it equal to 0. So we get 2x squared minus x plus 0 equals 0. Do you see how they both went away because they inverted each other? Negative 1 plus 1 is 0. I could write 0 there, but usually we don't write nothing unless it's on the side of the equation all alone. And now we need to, everyone's favorite, factor. This one's easy. We take the x out. X factored out of here is 2x minus, so you're dividing both parts by x, right? Factor is the opposite of distributing. It's the inverse of distributing. So x divided by x is not 0, it's 1. This is talking about the identity in arithmetic. I haven't actually done a video on the identity yet. Maybe we'll do that tomorrow. So now you can say either, so if this is a multiplication, which it is, this is like a times b equals 0. So logically, anything times anything, if it equals 0, that the only way to multiply and equal 0 is if one of the parts is equal to 0. And in this case, the part you're looking for is actually the intercepts of this negative 1, right? So when the function ends up being negative 1, okay, that means that either x equals 0, so that's the a part, that's this part, or 2x minus 1 equals 0, in which case we have to solve that. I'm going to make that a little simpler for us. Or 2x minus 1 equals 0. I like to do it this way. I did it the other way. So add 1 to both sides. 2x equals 1, x equals 1/2. Okay, so these are the solutions when the function is negative 1. So the question says, function of x, if function of x equals negative 1, what points are on the graph of f? So if you tell your teacher x equals 0, x equals 1/2, you got that problem incorrect, right? Because that's simply an x value, and you're being asked for points. Points are always x, y, right? So both of the y values are going to be negative 1. You're going to get 0, negative 1, and 1/2, negative 1. Okay, are you with me on the logic of that? We got our two answers of 0 and 1/2. 0, 1/2, and it's because we plugged in negative 1. Okay, those are the answers. Now the question is domain and range and intercepts, if any. So the domain is, we're allowed to pretty much put anything in. If we look at this, it's just going to be all real numbers. And the range is a parabola. This original problem didn't ask for range. I added it because I wanted to be snarky, being silly. So in order to contemplate the range, you need to know where the vertex is of this particular graph. And if you look, do you remember this of vertex? I don't know if you do. So, and suddenly I'm blanking out on my vertex form. X minus h. squared. Let's see. Well, I'm going to have to figure out the vertex. Get back to me on that. We'll figure out range later. I'm not thinking for a second. And the intercepts, if any. So function, if f equals 0, when x is 0, that's the y-intercept. So f of 0, this becomes 0, 0, and -1. So the intercept, y-intercept, equals -1. Now, the x-intercepts are when the whole thing equals 0. So function of x equals, let's just be clear of what I did here. There's an x, the x is going to be 0, that means this whole thing becomes 0. This x is going to be 0, so it's 0. The only thing left is -1. It's really easy to find the x-intercepts. The y-intercepts are always a little bit harder because you've got to do some math. You've got to do some factoring, some solving. 2x squared minus x minus 1. This is what equals 0. So I'm going to swap the equal signs so you can see it. So 2x squared minus x minus 1 equals 0. And we've got to factor. We have to factor, or we have to use the quadratic formula. Do you remember that bad boy? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Do you remember that? I had a student once who said to me, this is like Pop Goes the Weasel. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And I don't know about you, but once you hear that, you can't unhear it. It never goes away. Okay, so this is our last resort, but let's see if we can factor this. So if we were to factor it, it's got to go like this. And it's got to be 1 and 1. Because you have to multiply to get a 2 here. And you've got to multiply these to get a -1. So the question is, can you somehow sum these to end up with -1x? Actually, you can if the 2 is negative and the 1x is positive. That actually, I'm going to talk this through. 2x, I'm going to multiply this, right? We're going to FOIL. I'm going to change the color so you see it. First, 2x squared. Outer, 2x times -1, that's -2x. I'm going to write it here so we see how these join. Inner, -1x is, or excuse me, +1x is plus x. First, outer, inner, last. 1 times -1 is -1. So that's this. So these two things combined become -x. That's how I know I factored it correctly. We'll go back to black and I'll rewrite it. Do you see it? Now, so this is our factor. So now, much like this, right, where we had to set it equal to 0, we now just need our two answers. So that means 2x plus 1 equals 0, or /nx minus 1 equals 0. This is just to build a wall. I'm building a wall. So 2x equals -1, x equals -1/2. Now remember, these are intercepts. So when x is -1/2, y is 0. And when x is 1, y is 0. Which I feel like way up in our problem. Did we already figure that out? That was a different problem. So there's the intercepts. And in fact, then that gives me a little bit of a sketch. And then I'm going to come up with my range. So if I did a little sketch of the xy coordinate plane, I know that I've got 1 and -1/2. By the way, negative b over 2a is the vertex, which I can come up with in a hot second. It'll help us get the range. The y-intercept is -1. So the vertex is going to likely be right through here at 1/4. In fact, do you remember ABC? ABC, easy as 1, 2, 3. I'll say, well, it's do, re, mi, A, B, C, 1, 2, 3, baby, you and me, girl. If you're going to watch my videos, you got to be used to random acts of singing. You just have to. Okay? A, B, C, A, B, C. If you remember from the quadratic formula, negative b over 2a is the vertex. So negative b over 2a equals 1/4, and that is approximately where I put this in when we put 1/4, and that's why they didn't ask for the range. But I did. You guys were almost at the finish line because we have one question left to answer, and that is the range. Oh, where the deer and the antelope play. When I put 1/4, I'm looking for what is the value right here. Do you see? This is my, I'm going old school. They didn't ask us for the parabola, but it always helps to sketch it. So I'm going to put this 1/4. Okay, the vertex is right down here. It's so close. Okay, I'm going to guess it's actually right there. I'm going to guess it's 1 1/4, aka 5/4, but let's put it into our equation. So we know our equation is 2x squared minus x minus 1. So the function at 1/4, are you seeing this? Is 2. 1/4 squared minus 1/4 minus 1 is equal to 2 times 1/16. Sweet Lord. Oops, minus 1. Well, now we're really cooking with gas. So 2 times 1/16 is 1/8 minus 1/4 minus 1. Replay this part if you have to, because I am getting a common denominator like I'm slicing through butter with a hot knife, because this is 1/8, this is -2/8, and this is -16/8, my friend. So that means we get -17/8. Yeah, that's right, which is approximately, well, it's exactly 2 1/8 negative. Look at this bad boy. Oh, 2 1/8. So the y, the range, is going to be, gotta go way back up here. The range is all real numbers such that y is greater than or equal to -17. That was fun. You see it? Let's just enjoy our work for a moment. I'll put it this way. Look at how much work we did on one problem. Now, do you normally have to write all that down? Oh, I forgot to record this. That's really sad. Do you normally have to write all that down? No. But is it a good thing that you did? Yes. Okay. So what is the point of this? The last problem took the longest for sure. The first, and in the original textbook, they didn't ask for this, which is the hardest spot. These three are all pretty quick, right? But it's interpreting what is the question asking for. So keep it up. Good work. Please like, subscribe, share. Just trying to help people understand math, because it is both my blessing and my curse, and I want to give it away for free, okay? Make the world a better place, buy the world a Coke, all those things. Sing a song. Sing a song. Sing it loud. Sing it strong. See you next time, kids.